Welcome to qnawire.
So now we'll work on problem 100 from chapter 20. In this problem, we're told the information about gold, which exists in two common positive oxidation states, +1 and +3. The standard reduction potentials for these oxidation states are for the reduction of gold 1 is 1.69 volts, and for the reduction of gold 3 is 1.50 volts. And in part A, they ask us, can you use these data to explain why gold does not tarnish in the air? So these reduction potentials of gold are high. They're very positive, which means that it's going to be hard for the opposite reaction, the oxidation, to occur. So in the air, we have oxygen, nitrogen, things like that. If we go to Appendix D and look at the reduction potentials related to oxygen and nitrogen, we can see that we don't have any reduction potential for these species, which is higher than the reduction potential for gold. So that means that oxygen or nitrogen cannot oxidize the gold, which means that it will not tarnish. In part B, they ask us, suggest several substances that should be strong enough oxidizing agents to oxidize gold metal. So we've already established that air, oxygen, nitrogen cannot oxidize gold, but now we can look through Appendix D and we can look for reduction potentials which are larger than the values for gold, which are 1.69 and 1.50. So we find that there are several that are larger. We have ozone, which has a reduction potential of 2.07. There's also hydrogen peroxide, H2O2, which has a reduction potential of 1.78. There's cerium 4+ with a reduction potential of 1.61. And the last one given in the Appendix E is the F2 molecule, fluorine. The reduction potential for fluorine is equal to 2.87. So all of these molecules here should be able to oxidize gold. In part C, we're told that miners obtain gold by soaking gold-containing ores in an aqueous solution of sodium cyanide. A very soluble complex ion of gold forms in the aqueous solution because of the redox reaction, which is shown there. What is being oxidized and what is being reduced in this reaction? So first we can go ahead and copy down this reaction to show clearly. We have 4 gold plus 8 sodium cyanides plus 2 water and an oxygen molecule, producing this complex ion with 4 sodium connected to, or 4 of these complex ions. And 4 sodium hydroxides. So the question is, what's being oxidized and what is being reduced? So here we can see gold has a charge of 0. And we can see that over here, gold has a charge which should be, we have a positive charge here, we have 2 negative charges here, so gold should be positive 1 to neutralize this charge. So we have +1. So that means that gold is being oxidized. Now the question is, what is being reduced? So we can see oxygen here has a charge of 0, and over here has a charge of -2. So that means that this O2 molecule here is being reduced. In part D, we're told that gold miners then react the basic aqueous product solution from part C with zinc dust to get gold metal. We need to write a balanced redox reaction for this process and then answer what is being oxidized and what is being reduced. So we have this sodium gold complex being reacted with zinc, and it's producing gold metal. That's all we're told. So there also should be other compounds in here. So first we have a hydroxide anion. And so what this does is the zinc displaces the gold, and we have zinc cyanide 2, and then we also form sodium hydroxide, which is removed by the hydroxide ion from this complex. So in terms of what is being reduced and what's being oxidized, we can see here gold is going from +1 to 0, so gold is being reduced. And zinc is going from 0 to -2 to +2. So zinc is being oxidized.